Let's begin our first malware analysis series by analyzing Emotet Malware. So Emotet Malware, as you can see, was disguised as a payroll invoice document. And this malware variant was specifically used by threat actors to target banking institutions. So we'll begin our analysis by using the Ubuntu virtual machine. So you can download Ubuntu from the official website and set it up as a virtual machine. And the tools that we'll use for static analysis for the Emotet variant include Didier Stevens Suite, and also we'll use Oletools. We'll use both tools to try and extract the basic structure of the file, see if any VBA macros are embedded within the document. We can check any objects that are within the file, and we'll use these tools for our first static analysis of the labs. So unfortunately, cyber criminals can exploit this vulnerability and embed payload inside Word documents. So Oletools can be used to dig deep into these Office documents and analyze any embedded malicious code like macros, VBA scripts that are used to trigger malware when a document is opened. So tools like Oletools can extract and analyze these hidden components and help analysts detect and reverse any malicious action. So in our case, we're going to use both tools to identify how the structure is, check if there are any hidden macros, then we'll proceed from that. So we'll start with one of the scripts that is within Oletools, that is called oleid.py. So it's a Python script that is used to check for suspicious elements and file details within Word document files. So in order to execute our script, I'm going to type the command python 3 oleid.py, then we'll give it the name of our payroll invoice document. And once we execute it, as you can see, it gives you the file format, which is a Microsoft Word 97 to 2003. The container format is OLE. The application name is a Microsoft Word Office document. But what you're particularly interested in is the VBA macros, which is marked as suspicious. So if it's marked as suspicious, then it could give hints that this file contains a VBA script, and some of the keywords that were used in this VBA script were found to be suspicious. So for the rest of the details, it has zero encryption as shown over here, but we can check it further and check some of the extracted macros that we'll get from the source code. So in order to analyze that, we're going to use another different script that comes with Oletools. So the name of the script is olevba. So olevba particularly tries and extracts all the hidden VBA scripts and macros that are within this Word document. So we've already identified that this document already contains a suspicious VBA script, and we want to extract it and analyze it and see some of the details that are within that specific script. So in order to do that, we're going to use olevba. Then we're going to use the -c command, and we'll give it the name of our payroll invoice. So we'll try with the -c command. And as you can see, we've extracted all our VBA script, and this is the source code for the VBA macros. And as you can see, most of the VBA script is actually encoded, and it's obfuscated. So we're going to try and de-obfuscate some of these encoded script. So what I did is we can just copy all of this, and I have it pasted over here. So this is the VBA script that we extracted using oleid.py, and we'll start with the first variable over here. So we can copy this variable, then we'll use base64 decoder to try and decode this specific string and see what we'll get. So for the source character set, leave it at UTF-8, then we click decode, and the first details that we get is PowerShell. So this script might be trying to open PowerShell and execute some sort of code that we are not sure about, but we'll try and decode some of the other strings and see if we can get other hints. So maybe we can try with the second variable. So for the second variable, we can see there's some sort of command over here, windows system.test. The rest is also obfuscated, but this looks like a command that is being executed on the PowerShell terminal. We can try with the third variable. Okay, let's try with the other variables. So this looks like part of the PowerShell script code, and we can see URLs over here. So you might be trying to access a website, or maybe try and download a different program from the website. Maybe it's an executable it's trying to download. So we can try with the other variables. Let's try with this one. So we already have hints that this specific VBA script is trying to access PowerShell and execute some sort of command from the PowerShell terminal. So what we're going to do next is we're going to try and check if there are any suspicious elements and any malicious VBA macros. So we're going to use the same tool, which is oleid VBA, and this time we'll use the A command to extract all the suspicious elements, any indicators of compromise, any malicious scripts, and we'll see from here. So we'll change the C command A, and as you can see, we have an auto execute VBA script that is called document_open, which means that this specific script executes once the document is opened. The first suspicious keyword that we have is shell. So it may run an executable file or a system command. In our case, we've noticed that it's trying to open PowerShell. There's another suspicious keyword called call, which might try and call any DLL files. using the macros. So for the CHR, this is used to obfuscate some of the specific strings that we have over there. And what you've noticed is most of the strings are encoded using base 64. So we have a new object keyword that is trying to create a new OLE object. And we've already denoted some of these suspicious keywords that are called by this specific variant. So we've checked and we've noticed that there's some of the specific codes that are within the VBA script, and we've tried and de-obfuscated them, and we've decoded and seen that some of the commands call to PowerShell, and there's a specific command that is executed on PowerShell. We've already seen that there are suspicious keywords within this specific payroll invoice document, and the VBA macros within this document has been flagged. So we're gonna switch back to Didier Stevens Suite, and this time, this was the command that I used, Python 3. You can just run it again so that we can dump all the data streams that are within this specific Word document. And you can see we have around 18 data stream entries, and out of the 18 data stream entries, 4 of them are marked as malicious. So we have this specific entry for the data stream, that is data stream number 8, 9, 10, and 17. And if you go back to Oletools, where we tried extracting the VBA script, we can see some of the specific streams that are called. This is one of the streams which was already marked as malicious. So just to confirm, so we have our stream over here, 8VN. It's already marked as suspicious. We have other streams as well. So we have AGEH7QV. So if you go back, this data stream is also marked as suspicious. So we have a total of 4 data streams that are already marked as suspicious. So we're gonna switch back to our Flare virtual machine and continue the static analysis of our Emotet variant. So just to confirm, we're gonna see if our DNS configuration resolves to the INET simulator. Remember, we still have REMnux virtual machine running our network simulated traffic. So we're gonna confirm if the DNS resolves to the REMnux machine. So we can confirm that our traffic is still running through the INET simulator. So the first thing to do is hash the file and check the MD5 hash value. Then we're going to submit this hash value on VirusTotal, and we'll see if this variant is already submitted on the platform. So click your start button. You can use any tools to hash the files. I'm using hash files so that I can get the MD5 value. So hash my files, then click file, click add files, then we'll select our payroll invoice, which is the Emotet variant we are analyzing. Click on open, and we have 2 submissions of the MD5 and SHA-256 values. So we're going to use the MD5 value. So if you go back to VirusTotal, it gives you an option to submit a hash of a file so that you can see if the sample is submitted online. So we're going to type this hash. D43 707 DEA 7AC So we're gonna cross-check the hash, confirm that everything is correct. So click search so that you can search for this hash. And as you can see, this variant is already submitted. And as you can see, it's labeled as payroll invoice.doc. And it's already submitted on Virus Total. And it's detected by around 48 security vendors out of 64. So we can confirm that this file exists and it's already submitted as a malware variant. So for the next step, since we already have the hash, we're gonna load the VBA macros. But before we load that, we're gonna continue with the static analysis and check some of the VBA scripts that are loaded by this invoice. So now we'll switch to off-base tool that gives you the corresponding hexa offset values of the Word document, which we'll see and compare with the corresponding ANSI values. So to launch off-base tool, double click on the executable. Then we're going to specify our file. So click File, open Data File, and we look for Emotet variant, which is our payroll invoice. Once you click Open, we're going to load a parser, and in this case, we'll utilize the Word binary format parser. So right here it gives you the offset value of the document, then it will pass all the data from the offset values and gives you the corresponding string. So we'll click on Pass. So if you check our data stream, then we can scroll down and check the corresponding ANSI values on our data stream. So this one gives you details about the file, which is a Microsoft Word 97. What you want to look at is the specific URL that this variant tries and requests to. So on the right side of the offset values, we have the passing results that gives details about the corresponding offset values and the related OLED structures that are found within this specific Word document. So what we want to look at is the Word document stream, and we will check the data section. Then we can take a look at the corresponding ANSI values and see if we can get any details on that. So in the data section, So first hint we get is the type of the document, which is a Microsoft Word document. Then what you will also notice is that this file executes a dynamic link library file called MSX M13. So we have an execution of a DLL file called MSX M13. We can also notice that we have a VBA macros that is embedded within our document. And if you check the ANSI string, we can see that there is a shared VBA over here for the application. And we also have various objects that are within the file structure. Then we have the version, the XML version, which is version 1.0, that uses UTF-8 encoding. So this is some of the data that we have obtained from the corresponding offset values in the data section from the passing results. We notice some of the embedded URLs within this structure. So the first URL that we noticed is this one over here. And we also have other different URLs that are embedded on this document. We have another URL. There's another one over here. So URLs include calls to Photoshop, Adobe, and we also have the modification date over here, which is 2017 on the 28th of March. We have the document ID. We have a different URL call within the same embedding. You also notice that the VBA script uses base64 encoding. So all these details can be found from the passing results in the data stream section of the Word document. So we'll open the payroll invoice on Word document. And Microsoft typically has a feature where it can open documents in protected view. This prevents documents from executing any hidden malicious scripts that may be embedded within the document. So in our case, we're going to click Enable Editing since you're already executing this in an isolated environment. But before we proceed to enable the macros, we're going to view the macros and see some of the macros that are loaded. So if you click macros, click view macros, we can see that we have a macro named document_open. So for this macro, once you click edit, we can see that we have a VBA script over here, but most of the written characters are in encrypted form and obfuscated. So the engineer of this malware might have used this technique to hide some of the code that is executed by this VBA script. So if you check some of the modules that are loaded, double click, we can see we have a module over here. It has a bit of code and encrypted characters, but we have our first hint over here where the data type is being base64. So we can say that some of the encryption methods that are used to obfuscate this VBA script is base64. So they use base64 encoding to hide most of the script. If we load the second module, we also get details on that. You can see some of the code is left unhidden, but you can see hints that base64 encoding has been used. For the last one, we still have encrypted content and most of the code has been obfuscated. But we can already see that from our static analysis, most of the code is already obfuscated from the VBA script. We can confirm that the document loads VBA macros when automatically opened. And this completes our first phase of our static analysis. We will proceed to the second phase and we'll enable all the macros and we'll try and check some of the traffic that is intercepted on Wireshark and also some of the current processes that are loaded. We're going to continue with the second phase for the dynamic analysis. And before we start anything, we're going to start Process Monitor so we can monitor all the processes that are running on our system. So we'll start Process Monitor. So Process Monitor basically gives you an overview of the current time, the process name, process ID, the operation that the process executes, the path, if the operation was a success, and the details that are registered from the process. So as you can see over here, these are the current running operating processes in our system. Then we'll start Wireshark as well so that we can intercept traffic. And the good thing is we've already set our environment to simulate network traffic. So any requests to communicate with the internet from the malware will still be captured from our simulated traffic. But in our case, since we've already resolved the DNS address to the INET simulator, most of the web pages or anything that is downloaded as an executable will not run. So in our case, it's a safe environment. All the requests to the websites will be made, but none will be executed. So we're gonna start Wireshark. And remember, we will start this capture on our Ethernet interface that is connected on the host adapter that we created. So once we start the captures, you'll see a couple of requests. These are some of the simulated requests that are coming from the iNet simulator. So we might see some traffic once we start the capture. So in order to start the capture, right click on the Ethernet interface, click Start Capture. And as you can see, we already have traffic coming from our iNet simulator. Then we'll go back and we'll execute and enable our macros. So in order to enable macros, we're going to click Enable Content. And once we click Enable Content and all the macros are loaded, our machine is already infected. And right now, we can start intercepting the traffic. And as you can see, we have traffic coming from our machine. And we can also see some of the current running processes. So what we typically look at for this Emotet malware variant is the WINWORD application, because this malware variant is disguised as a Word document. So if you notice, we have a couple of applications from WINWORD. And if we can narrow down the processes and view the process tree, we can see some of the process trees that are over here. So we're gonna give it some time to load all the processes. And as you can see, our WINWORD executable is executing a PowerShell script, which already is a malicious activity, because a Word document is not meant to execute any PowerShell script. So some of the VBA script that is encoded within this document might be trying to open our PowerShell script. So as you can see, we have a couple of URLs, and some already match the URLs that were submitted on VirusTotal. So we also have a couple of new websites like these ones that are not yet submitted on the VirusTotal submission. So as you can see over here, we have around 5 URLs, and we've already detected 2 URLs that are communicating with this variant from our Wireshark traffic capture. And we have other new URLs that are communicating with our variant. So these are some of the denoted and captured URLs that originate from our traffic. And as you can see, the source and destination IPs are the IPs of our REMnux and Windows machine. And just to confirm, if you check the VirusTotal submission, we have a couple of domains that are contacted with this variant. So we have Explore Free Results, Grace the Web, RGV2, and so on and so forth. So we'll confirm on our traffic if we still have the same domains. So we still have the same domains, RGV2, and new domains. Let me check if this one is already mentioned. So we have this domain as well. todofrog.com is another domain that is contacted and intercepted by our Wireshark traffic. So there we have it. From our Wireshark traffic, we've already known some of the URLs and some of the domains that this variant tries to communicate with. For the IP addresses, since we're only specifying the IP addresses within our host's network adapter, then the IP addresses will be the ones that are assigned by a DHCP server within the specified addresses 10.0.3 and 10.0.4 IP ranges, 10.0.0.4. So there we have it. We've already confirmed that our malware variant is trying to communicate with a couple of websites. And if you want to dig further on that, you can do a whois lookup on some of the websites. Maybe we can do one. So we'll do todofrog.com. So we're gonna do a domain lookup, a whois lookup on the domains that we've already detected. I already did a whois lookup on some of the domains that were detected, and some of them have been revoked. So we'll try with this one and see the results that we get. Remember, rjv2.com is seen appearing on our Wireshark traffic. So this is the domain that we're going to check. And from the description, you can see that it's coming from GoDaddy using the IANA ID 146. So we can say that this malicious actor registered this domain on GoDaddy. So some of the domains actually show up, and if you try with some, they are not available. So if you try with this one, as you can see, some of them are not registered and some are revoked. So we'll go back to Process Monitor and see some of the current processes that are loaded once we enable our macros from our payroll invoice. And as you can see, our WINWORD application is what we'll focus on, because this variant automatically opens WINWORD application to start the Word document application in our system. So there's a couple of red flags over here. As you can see, we have registry key queries, and some of them might be edited. So if we click on tools and we view the process tree, then we can see a WINWORD executable that is running on process ID 6924 is loading a PowerShell executable, which is also malicious, and they have start times and end times. So for the first start time, our WINWORD executable, then the PowerShell script, then we have our console, which is our Windows terminal over here. So we have a PowerShell script that is executed and a command that is executed on our Windows terminal. So a couple of things to check is the registry keys that are modified. So when you check our process tree, we can see that the WINWORD executable loads a PowerShell executable, which executes the following command. So this is the command. From this PowerShell script, you can see that it's trying to access some of the websites that we've already mentioned from our Wireshark traffic. And all the files are being stored in the temp directory, which can remain hidden. And we have a web access client command to download specific files to our temp directory. So this is very suspicious in our case, because most Word documents don't automatically access these said URLs, and they don't download files. A filter on our process monitor so that we can get the specific process ID that is associated with our WINWORD executable. So click PID Then our process ID is 6924. Click on OK. So we'll add it, then we'll apply and click OK. So we'll disable the rest. Right now we have the processes that are associated with our ID. And if we try and check some of the registry query values that are modified. So this one tries and access the current version registry key from HKLM software. And in most cases, if a file tries and access this specific registry key, then it's trying to enable persistence in our system. So in most cases, if you see a malware variant that is targeting this specific registry key, then it's trying to enable persistence. You also have other registry keys that are accessed. So this one is the session manager. So in essence, this variant is trying to control current sessions that are operating in our operating system. And in most cases, if it's trying to control the sessions, then it's trying to take most of the resources that are within our system. So in order to do that, if you try as much as possible, control most of the sessions. We can see modifications to that as well. This completes our first malware analysis lab, where we analyzed our Emotet malware variant, social engineered as a payroll invoice. We checked some of the processes, and we've seen that there's a malicious PowerShell script that is executed once the process loads. We've seen some of the hidden macros and extracted some of the VBA script on our Ubuntu forensic machine. We've also seen that some of the data streams within this particular document is marked as malicious. So if you have any questions, you can drop it in the comment section. Make sure you like and subscribe. We'll drop a new video soon where we'll analyze our next malware variant.